Hello there! In the previous episodes we've already learned how basic map transforming works as well as how to apply texture. In this episode we will learn how to apply proper lighting to our map as well as how to render light maps. We will discuss all different types of light sources, the engine support, as well as how ambient light, skylight and fog works. My name is Vortex and let us shed some light into the dark. Light sources. Sauerbraten has 5 types of light sources: point light, spotlight, sunlight, ambient light and skylight. Point lights. The most basic type of lights are point lights. They are entities to be placed around the map which will cause static shadows. To add a new point light, simply click anywhere you'd like the source to be placed. Then press T and enter /new end light size red, green, blue. Size can be any value between 0 and 32,765. Red, green and blue can be any value between and including 0 up to 255 each. A size of 0 means the light has no fall off, hence it casts infinite shadows. Also, a size beyond 512 makes little to no sense in most cases, as we probably better advise to use sunlight instead in these cases. Press K on your keyboard to let Sauerbraten calculate light maps. Spotlights. Spotlights are actually not a new type of light, but rather an addition to any point light in the map. To create a spotlight, simply select an area where you want the spot to point at and press T. Then enter /new end spotlight radius, while radius can be any value between 0 and 90 degrees and indicates how narrow or wide the spot angle is. Also, spotlights do automatically attach themselves to the nearest point light. Press K on your keyboard to update light maps. By selecting any of the mentioned light sources using the mouse wheel, you can also increase and decrease the light and spot radius without the need to place a new one. Sunlight. To simulate proper sunlight, some does not have to use point lights of radius 0. We can use actual sunlight. Press T and enter /sunlight red, green, blue to set the map's sunlight color, which by default will shine from top to bottom. By default, sunlight is set to 0, 0, 0, and hence, if we compute light maps, our map will appear grayish, or better said, be colored in the shade of the map's ambient and skylight. We will learn more about them later on. To change the direction in which the sunlight casts its light, we can use /sunlight pitch followed by a pitch and /sunlight jaw followed by a jaw. Pitch can be any value between 0 and 90 degrees and indicates the sunrise. 90 degrees being from top to bottom, and 0 will cause the sun to lit the scene from the horizon. Jaw can be any value between 0 and 360 degrees, which will in return rotate the sun around the global z-axis to change the coordinate direction from where the sun lit the scene. Using sunlight scale, we can set the overall intensity of the sunlight, while intensity actually is not the right term to use here. I'll explain this later on. The scale itself can be any floating point value between 0 and 16. The default is 1. Another importance about sunlight is it is the only light source casting dynamic shadows in the game. Dynamic shadows are cast by everything in the game except the map itself and doors. Or in other words, does it move? It has dynamic shadows. If it doesn't, it don't. Well, except for doors, they simply have no shadows whatsoever. Therefore, players, pickups, monsters, barrels, boxes and elevators, most of which we will learn more about in later episodes, will cast dynamic shadows. But another exception about sunlight is that only the sunlight jaw affects the direction of dynamic shadows. The pitch only controls their prominence. In other words, a pitch of 0 will make dynamic shadows disappear or fade out entirely, while higher values will make them to slowly reappear. Therefore, a low pitch, which will make the sun lit the scene from the horizon, will just make dynamic shadows disappear. In fact, the dynamic shadows use the pitch to simulate some sort of a day and night-like effect, while the engine itself does not really have an actual day and night cycle. Therefore, the pitch does not change the actual direction of dynamic shadows, unlike it does with static shadows. As much as the shadow cast direction of dynamic shadows is concerned, sunlight only affects the rotation around the global z-axis by changing the jaw, while the pitch is always a steady 45 degrees, again concerning its direction. To update the sunlight even for dynamic shadows, we have to press K to recalculate all light maps in the scene. Ambient light. Ambient light, as the name suggests, is used to lit the entire map to make it appear overall brighter or darker. By default, the ambient light is set to 25 in all three color channels, red, green and blue. To change the ambient light, press T and write /ambient red, green, blue, while red, green and blue can have the values 0 up to 255. You can think of ambient light as the color of shadows. Therefore, brighter ambient light will cause brighter shadows, or make them appear in any given color. After changing the ambient light, we also have to press K to recalculate light maps. Also, the ambient light directly affects the color of dynamic shadows. Skylight. Another form of ambient light is the so-called skylight, which by default is off. All color values are set to 0. To change it, use the /skylight red, green, blue command, while red, green and blue can be any value between and including 0 and up to 255. You can think of skylight to be the primary color of the sky, which is then multiplied with the ambient color. You can use this to have a more shadow-like ambient light, hence not matching it the fog or sunlight color, and just keep it dark or grayish, by using the skylight to change the overall tone according to the sky color. In other engines you would probably call this global illumination, while global illumination in other engines also takes the color of surrounding parts of the map into account, which Cube 2 does not. Looking at the screenshot shown on screen, we can see the difference between ambient and skylight just fine. While the exterior shadows have a more reddish tone as I set the skylight to red, and the interior shadows are more greenish as I set the ambient light to green. What the engine actually does here is to use the fall off of shadows to multiply the sky color with the ambient color. In regions where the shadow is stronger, the ambient light has more influence, while in areas where the shadows start to fade out, the skylight becomes more prominent. For dynamic shadows, both are just equally merged with each other. Fog. While fog is not exactly a type of light, it still adds some atmosphere to the scene, which is what lighting is basically about, atmosphere. There are two fog properties we can set, the density and the color. To change the fog's density, press T and enter fog followed by its density, while the density can be any value between 16 and an insanely huge number. The default density is set to 4000. A lower density means the fog appears sooner, while a huge density makes the fog to start later. You can think of it like the distance to the player's view until the fog starts to appear. If you want a clean looking map, you can turn the fog density to a high value, while on foggy maps you may want to use lower values. To change the color of the fog, press T and enter /fog color, red, green, blue. The default values are 128 for red, 153 for green and 179 for blue. Changing fog does not require us to recalculate light maps as it is applied on the fly. Using light properly. While we now know about the basics of lighting in general, I'd like to give some good practice on how to use all techniques we've learned for best visual fidelity. My personal recommendation is to set the skylight and fog color to approximately the same color of our sky itself, while using the ambient light to simulate some form of global illumination, hence set it to some shade of our most prominent ground texture, while the sunlight can be a regular sun color. For example, if we happen to build an underwater map, we may set fog and sky color to some shade of blue, while the ambient color can be similar to the sand texture we've probably covered the ground with, and setting the sunlight to some white or slightly yellow or orange tone, just as the real sun. Maybe even turn up the scale a bit. On a space map, we might set sky and fog color to black, set the fog's fall off to an insanely huge value, and make the ambient color all black too, by making the sunlight somewhat more intense by increasing its scale. If we want to get back to modeling and don't want to see any light, we can, while in edit mode, press L to toggle the full bright mode on and off. This will hide and show all light maps. Light maps. While we have talked about all the different types of light, there is still more to know about light maps in general. Light maps are actually the light baked into a texture, which is then just layered on top all the other textures in our map. Here we can control various values of how the engine will compute those light maps to tweak their overall quality. Light precision. To control the precision of light, we can use the command /light precision followed by a precision value, while the precision can have any value between 8 and 1024. The default is 32. The precision actually controls the resolution of each light map. Lower values are actually of higher resolution than higher values. You can think of it like as if the engine lays an 8x8 pixel grid onto the entire map and just determines if it should make one of these 8x8 squares black, hence it has a shadow, or not. It cannot paint in between these blocks. In other words, it is the blockiness of the shadow. It is actually how even modern game engines calculate light maps themselves. If you have lots of small structures, it may be advised to set the precision to a lower value in order to avoid light to bleed around walls or around corners. Keep in mind, more detailed light maps will also vastly increase the size of our map file. Light quality. While light precision is the most noticeable way of controlling the overall quality of light maps, there are a few more values we can tweak, even though they have only very subtle impact on the result. Using /blur skylight followed by a blur value and /blur light maps followed by a blur value, we can change the blurriness of both types of light. Each can be set either to 0, 1 or 2. Using light LOD followed by an LOD value, we can control how much light bleeds around corners. This is best seen on high maps. A high value will make edges appear less shadowed, while low values will cast harsher edges. The LOD can be any value between 0 and 10. With light error followed by an error value, we can also control the correctness of casted shadows, while its effect is not very visible. Not to say I cannot spot any difference between low and high values here, but for the completeness of this video I include it anyway, so there you have it. Outro. So much for lighting. I hope you found this video helpful and are now able to touch up the visual tone of your map just fine. In any case, happy editing and see you in the next video.